Hi, Nicolas.
Hello.
Hi, you're online? Hi, nice to meet you again, I should say. Thank you for being our guest today and our speaker. And I also thank the audience for being here and for listening to this super exciting Kubernetes talk. Nicolas, you might want to tell us a bit about yourself, what you do and what your background is on software development and how you came to this talk today.
Yeah, sure. So I'm Nicolas Fränkel. I've been a consultant in the Java ecosystem for like 17 years. And nearly 3 years ago, I decided that I had enough to do the same projects over and over again. And I wanted, let's say, to do different stuff in my career. So I went to the developer advocacy path, was providing cloud services. And so I became interested in this, and I dug in certain, because I also wanted to understand what all this stuff was all about. So I dug and dug and dug, and then I had this impression that you always had to learn Go, and I don't like Go as a language if you want to go into the Kubernetes ecosystem. And yeah, there's this conflation of, hey, let's create an operator to ease the life of your users, but then it's all about Go. I didn't like it, so I wanted to understand by myself. I mean, how could you create one? So this talk could have been like named Kubernetes operator the odd way, because there is no framework, there is no library, you just code by yourself. But I found it, of course, a bit too vain. But yeah, I hope that people will learn interesting stuff inside, and at least not think that a Kubernetes operator is something very hard to do or very strange to do, or that you need a lot of skills, because I believe that once you understand the basic building blocks, everybody can do it.
Okay, so you didn't like writing operators in Go, and you thought like, okay, let's look under the hood. How can we use different languages? And obviously use Java, which is, I think, the language which you're most familiar with.
Exactly. Well, it's not that I didn't want to write an operator in Golang. I didn't want to write anything in Golang at all.
Okay. Didn't you like it from the start, or did you were neutral and tried it, and then after a couple of days?
No, I tried it actually. No. I explained it in the talk. I mean, when I found writing myself Golang like I was writing Java like 15 years ago.
Oh, okay.
Like the language, I can understand the reasons for that. They are super close. The hardware is very similar to C. So if you come from a C background, probably it's an improvement. But coming from Java or Kotlin, then you go back to a lower abstraction level, and then you are missing a lot of stuff, in my opinion.
Okay. I don't know if you can talk about this, but you're working for Hazelcast, and is Hazelcast using Kubernetes internally as well?
Yes, we are. Well, we are not using. So first, what is Hazelcast? Hazelcast is a company that provides two products. The first one, our first product, is IMDG, in-memory data grid. So basically, we offer you a way to have your data structures distributed. So if you are in the Java ecosystem, which is, I mean, Hazelcast IMDG is written in Java itself, so we offer a lot of nice utilities for that. Then that means that you have the familiar map and queue and list and stuff. The only difference is that this is distributed. So if your, I don't know, one of your node shuts down, then you have probably replicas and backups that are distributed, so you don't lose your data. So you can access your data in a very, very fast way and still have some degree of reliability. Of course, you can still, in the end, dump everything into a database or whatever, but I mean, every time you need to go to a database, then you incur like performance decrease, because you need to have like something that is on the disk, and even with multiple layers of cache, then it's not that great. So we offer you like an in-memory cache and under a very convenient API. But it's not only in Java. If you are using Python, if you are using Node.js, if you are using Go, we also offer an API binding for all those languages. And the second product is called Hazelcast Jet. And basically, it leverages this Hazelcast IMDG to do stream processing in memory. So again, very, very fast. And our very famous use case for that is you want to verify a credit card transaction. So you cannot leave the customer hanging and call 10 databases and check that everything is fine. So what you do is you put all your data in memory, and then you have got a pipeline that processes and check the data that is already in memory. And so the customer it is not waiting for that.
Okay, so he gets he or she gets a nice user experience.
Yeah, exactly. I mean, the customer, the customer and the merchant, they both get a very fast performance.
And memory is fairly cheap.
I mean, it's always awkward when you want to pay with your credit card. Sorry?
And memory is very cheap, so it becomes more and more affordable to use in-memory technologies.
Exactly that, yeah. The fact that, I mean, our technology is very much in use is because memory is very cheap, and compared to the decrease in user experience when you want to pay by credit card and then you wait. I mean, it's not worth it. So many of our customers are financial institutions. They prefer to buy a lot of memory and put everything, I mean, the most important data in memory from the database, and get the data where it is on the moment's notice.
Okay,
again, it's distributed, so you all these distributed systems
have the reliability a bit, which was counterintuitive when using in-memory applications.
Yeah, you've got reliability. It's always a trade-off. I mean, if you put everything in memory and you have async synchronizations to database or file system, then you are very, very fast, but you might lose some data. On the other hand, if you put very, very reliable in most cases, depending on the database, but then you are very slow. So everything is a trade-off, and you need to find the right place. And we are sitting in the middle.
There is a question.
And trying to get on both ends.
Yeah, there's a question from a user. He wants to know if it's already possible to do rolling restarts of nodes when you upgrade your Hazelcast version.
I must check. That's a good question. And to be honest, I'm a bit far from those deployment issues. So I need to check. Please ping me on Twitter, and I will be very happy to put you in touch with our SREs who are basically very focused on that issue, on those issues.
Okay. I want to go back to Kubernetes, and I think this will be my last question, and then we're gonna go to your talk. If some of the viewers decide to also write an operator in Java, is there some GitHub repository where you commit your code to or upload your code that people can follow?
Sure. So normally in the video, I have a slide deck, and on the last slides, you will find all references to the GitHub repo, to my Twitter, to everything you should be required to have.
Cool. Thank you, Nicolas. You will be with us after your talk for Q&A, and I will start now your pre-recorded talk.
Hi, everybody. Thanks to be here for this talk about your own Kubernetes controller. And I assume that you probably have heard about Kubernetes. Kubernetes is this super cool platform
that allows you to deploy your containers, in general Docker containers, but not necessarily. And it allows you to have auto-scaling, self-healing. Well, a lot of features that were not available in previous architectures. And this is a bird's eye view of Kubernetes architecture. And you can really see that the central piece of architecture is this API server. So this API server is the one that manages everything and stores the configuration into etcd. So every time you need to do something in Kubernetes, you talk to the API server. When you write, for example, kubectl something, then you talk to the API server. And let's try to do this kubectl. Okay, so I written an alias, get pods -v6. And we can see that it's just a simple GET request. And you can see the HTTP code here. And we can get a bit more detail regarding the output. And we can see that it's JSON actually. So here you have the HTTP header and the response header. You've got just HTTP JSON. Now, this brings us to the controllers. You probably have heard about the term controllers. And actually, a controller is just a simple control loop. And a control loop that checks the state of the cluster and tries to fill the gap between the existing state and the desired state. And for example, there is this deployment controller. And let's say you want 3 replicas. And at some point, for whatever reason, there are only 2 replicas. Then the controller, the deployment controller, will see that there are only 2 replicas and needs 3. So it will spin on one more. On the opposite side, if you have more replicas, it will kill one. So that you always have the desired state. And this is, like, in a very simple definition, what a controller is in Kubernetes. The next question is, where are the controllers located? Well, there is no requirement, actually. You can have controllers running in the control plane, which is the case, for example, for the deployment controller, but you can have them inside the cluster in normal containers, or they can be outside the cluster as well. Again, there is no requirement for the location of a controller. And as you might have noticed in the title, it's how you can create your own Kubernetes operator, but I struck out operator and I wrote controller. But the reason is there is a slight specialization of the operator. Actually, an operator operates on a specific dedicated resource. So you probably know that you can create your own resource in Kubernetes. You can have this custom resource definition. So you have existing objects. For example, you have the pod, you have the deployment, you have the stateful set, or you have the config map. Those are out-of-the-box objects. But sometimes you might want to create your own objects. So the Kubernetes model is very flexible. It allows you to do that. And when you want to create such an object, it's called a custom resource definition. And for example, this is the way how you can create a new object called a hassle cost, and to make Kubernetes aware of this new object. And that's the only difference. Like an operator, it operates on a CRD, whereas a controller operates on an existing object. Ergo, if you know how to develop a controller, well, you just create an operator by copy-pasting the controller to operate on a new kind of resource. if you know how to develop a controller, you know how to develop an operator. So for the rest of the talk, we'll just talk about the controller itself. So as we have seen, there are not many requirements for controllers. Basically, the only requirement is it must be able to talk to the API server. And since the API server accepts HTTP requests with JSON payloads, well, you could create your own controller by using Bash, shell technologies, just very simple stuff. So the question is why you can see on the market a lot of operators or controllers written in Go. Well, from an historical point of view, this Kubernetes software was at the beginning written completely in Java. And because the JVM takes a long time to start and consumes a lot of memory, it was decided after some time to rewrite it in Go so to be closer to the operating system. And for this reason, you can find Go in a lot of different places in the Kubernetes ecosystem. And I don't know about you, but I don't like Go. I mean, I'm a Java developer, and when I learned Java like 20 years ago, nearly 20 years ago, I learned that you could create your logic and then you had this exception, and then the exceptions handling code was in a dedicated block so that you can read the business logic very easily. The nominal path, you can read it in a very straightforward way. Now, Go doesn't have exceptions, and a couple last year, I think there was a tentative, there was an initiative to add exceptions, but people rejected it. The community didn't want exceptions. So that in order to handle errors in Go, Go allows multiple return parameters, so that every time you call a method that a function that might cause an error, then you return the error code along the whatever return value you needed to return. So every time you call such a function, then you need to check that the error was nil. So there has been no error, which makes it very hard, in my opinion, as a Java developer to read such code, because I don't understand. I need to read only the get foo and the slice the bar and the check bar slice. But meanwhile, I've got all those error handling code blocks here. And yeah, this is meant as a joke, but probably if you're a Go developer, you might have a shortcut to create this kind of code blocks because they all look the same. Also, it might seem simple. I mean, a lot of people say, oh, but you just need to learn Go. Yes, you just need to learn Go, and I agree, it might be a good idea. I mean, for intellectual purposes. But for a company to decide to switch to a new language is not as easy as just learning the syntax. Actually, when I started Java, there were a lot of people already experienced developers that were experienced in C and C++, and they were also switching to Java. But you could read from their codes that they were using another language before, because they were writing Java in a C way. Likewise, when I taught myself Kotlin, at the beginning, I wrote Kotlin like I would write Java code. So I didn't use it in a idiomatic way. So it looked really like Java code written in Kotlin. So this way of writing code, so code in its own idiomatic way, takes a long time. Also, once you know the language, once you know the syntax, you are able to write it in the correct way. Well, there is a whole ecosystem around it. If you switch from Java to Kotlin, the ecosystem is quite easy because it's the same. It's both are JVM languages. Now, if you switch from Java to Go, then you need to learn about all those new libraries, and sometimes you are in multiple choices and you don't know which one to choose. And finally, you need to cope with the tooling. Like, I'm using, for example, IntelliJ IDE. Luckily, fortunately, there is like its Go counterpart. But if you are using Eclipse, then you need to switch to something else. I don't know if Eclipse handles Go. And how do you debug Go codes? In Java, you just like connect to even a remote JVM that runs with certain parameters. You can connect to it, put breakpoints. How does it work in Go? This is all the thing that you need to learn along the way. So in some cases, in some contexts, I would advise, if your team already knows language X, please use it. And because I know Java, well, I would like to use my Java knowledge. And so then now it's time for a little demo. So my demo is to create a controller, actually. And how can I do that? Well, first I will make a little project. So this is a POM, and as you can see, I have 2 dependencies only. The first dependency is the Kubernetes API itself. The second is just SLF4J sample, so I can log stuff. So the Kubernetes API library is provided by the Kubernetes group itself, and I think it's a Swagger library that generates the Java code. So that the problem is that the Java code is very, very close to the REST API itself, which doesn't make for a super great API. On the good side, that means that every time Kubernetes API is updated, the Swagger API is updated as well, and the client should get generated. So you have a very, very fast delivery frequency. And here, this is how it looks. I create a client from the default config, and I will just list the pod in all namespaces. And as I mentioned, you can see it's very close to the Swagger API because you need to pass a lot of null parameters because you don't need them in that case. And here I'm using Java 8 streams. So I will list the pods in my cluster. Done. I've listed the post in my cluster. If I want to do the same, let's check that it still works. Get pods all namespaces. Yes. So I don't get all the, well, I don't print out all the information. I've got all the information, but I only print the name. But as you can see, it's very similar. So here I have coordinates, 2 coordinates etcd, and here I have 2 coordinates etcd. So it's the same order, everything is exactly the same. And of course, right now, it's not, we cannot say it's a controller because we are not acting, we are not trying to fill the gap, but it's a good beginning. And the next step is actually now we will create the Docker image out of these codes. And in order to do that, what most people do is create a Docker file. And I'm super lazy. What I prefer to do, since I'm using Java, is to use the jib-maven plugin. And the jib-maven plugin is a plugin created by Google that allows you to automatically derive a container from a POM without a Docker file. So there are 2 goals. The first goal is when you compile, you send it to Docker Hub, so you don't need a local Docker install. But here, since I don't want to send it to Docker Hub and afterwards download it again, I send it to my local Docker daemon, so I'm using a dedicated goal. Something that needs to be pointed out is it's in the compile phase, so basically you don't need to create the jar. What the plugin will do is it will layer first a dependency layer and then a class layer, so that if you change your classes, then Docker doesn't need to rebuild the dependencies, the libraries layer. So if you just change your code, your generation can be quite fast. Also, something interesting is I'm using a distroless Java container, and basically I have no shell, no nothing. So it might be very hard to debug. So here I am not using the default one, I'm using the debug one, which allows me to have a shell. And finally, afterwards, I need to have the Kubernetes deployment. And here I'm using a namespace, dedicated namespace, and just a simple pod because I want things to be easy. And because I'm sending the stuff directly to my local Docker daemon, I have image pull policy never because I don't want to get it from Docker Hub. Now I will use scaffold to deploy it on my local Minikube. So every time I will do changes, scaffold will check the changes, will see something has changed, will recreate the image, and will redeploy it. So this is what's happening. And we can see here that what's happening is there is an API exception. There is a forbidden exception. So the difference is that now we are using the container inside the cluster. We are not having Java code from outside. When I was launching the Java code from outside, what I did is I reused the configuration from Minikube that sits in my private own folder. So I have all permission. Now I'm running as a normal pod. I don't have any special permission. And the good thing is that, well, you need to have permission to talk to the API server because even like getting data, making deployments or getting the list of pods is an issue. It might be a security issue. So we need to add some authorization because we want our pods to be privileged. And this privilege in that case is to be able to list the existing pods. So this is done in this file. And I say here I need a cluster role that will be named operator example, and it will be able to list the pods. Then I create a service account named operator service. And then I bind the two, this operator example and this operator service. And I use this here to say I will be using the operator service account name. And now finally, I'm able from inside the container to list my pods. But I have an issue right now. And this issue is the following. As you can see, it's not ready. It restarts every time. What happens? Well, the JVM starts, does its stuff, and stops. And Kubernetes asks, hey, pod, are you ready? And the JVM cannot answer. The container containing the JVM cannot answer because it has finished its job. So it kills it, and it restarts a new one. And it goes on and on and on and on. So the next step is actually to create a simple loop. So we will loop, we will sleep a bit, we will again print the stuff. Now, it should have created, yes, operator 1.2. And as you can see now, it loops all over without killing the pod. If we check the pod should be up now. Everything is fine. That's great. That's quite good. Actually, we can go, of course, a bit further. Like polling is not a super great use of our resources. What we want to do is actually we want to do some event listening. And there is the Swagger API allows us to do that. So we will create what is called an event handler. And as you can see, we still pass a lot of null parameters. But this event handler is actually very nicely done because you can see that if you have been using event-driven programming, you can see that what would you do on add, what would you do on update, what would you do on delete. This is kind of the stuff that you get. And if we check now the new code, this is exactly what you get. So if I deploy a new pod, then it will get written here. Let's do it. I will deploy a new pod from an Hazelcast instance. And we can see already here that, yeah, it has been aware of the changes and it has written whatever happens. Okay, get deployment. Okay, k delete deployment edge dead. Now we have new updates, and when everything will be finished, we will have a delete. Delete it. Everything is fine. So this way, this polling versus even listening, well, even listening for the win. Now, finally, we are at the point, since we can act upon events, where we can try to actually do some controlling, to implement the controller. So far, we were just asking for information. And in that case, what I want to do is implement the sidecar pattern. Sidecar pattern is when I deploy a pod, I want to deploy an additional pod automatically. And that's actually a very good idea for a controller. And this is how we do it. The code is a bit harder to read because basically now we must think about a lot of stuff. So, for example, when I add a new pod, I will check first that it belongs to the right namespace. So basically, I will only deploy a sidecar when I am in the same namespace. And on the other way, I say, hey, I don't want this pod to be a sidecar itself. Otherwise, I will deploy a pod, it will deploy a sidecar, and the sidecar is a pod. So it will deploy a sidecar to the sidecar, and it will go and on, and I don't want that, actually. Also, I check that it doesn't already have a sidecar, just to be sure, and I create the sidecar. And as you can see, creating the sidecar is not super great. It's not super readable, but it gets the job done. So you basically read the Swagger API and you just use its API. How does it work? Well, now I should have this sidecar. So it tells me, hey, I have found my sidecar. And now if I get pods, you can see there are two pods. This one was the one I deployed by myself. And this one is the one that was deployed for me by my controller. What I want also to do is when I remove the main pod, I want to remove the sidecar. So let's check that it works. Sorry. So k delete pod custom operator. And k get pods. No, it doesn't work. Because basically when I'm removing the pods that should remove the sidecar is already gone. So it doesn't work like this. So the way to manage that is not the right way. What we need to do is to use something called the ownership in Kubernetes. So you can say that a pod is owned by another pod. And in that case, when you remove the owning pod, automatically Kubernetes will remove the owned pod. So this is the next step. So now we don't do anything on delete, but basically when we create the sidecar, we add this owner reference. And you can do it in YAML actually. We add this owner reference. Now we still have these get pods, but when I delete pod custom operator, now you see that it has been automatically removed. The next step is I actually mentioned it several times. I don't like this API. This API is super close to the REST API. And, well, let's say there is another one that is called Fabricates. It's not provided by Kubernetes. It's provided by a specific company. But I prefer this API a lot. It doesn't change anything. It's just change the way that you write your stuff. And as you can see, if it looks very similar to YAML. So here what I did is I used the tabs to align it, and it reads like YAML. Like here, API version v1, kind pod, metadata, name, namespace, this kind of stuff. So if you are able to use your IDE to align it correctly, then you can have this kind of fluent API that reads very nicely. And it still does the same stuff. Here, I need to quit scaffolds. Yay, K, apply F authorization. K, apply F deploy. I quit scaffold because K, get pods. Yes, now it does the same. It works pretty nice. Now we have an issue that I didn't mention before, is it takes a lot of, if I do Docker images, here, grep gvm, oh, I don't get them. Docker images, grape operator, yes. So as you can see, the latest one are 1.7 or 1.8 here. It's still around 200 megs. It's a lot, actually. So, I mean, Java for controllers is not that great. As I mentioned before, when you start the JVM, it takes small time to start up. Well, let's say non-trivial time to start up. And it consumes a lot of memory. The reason for that is that every time you send a workload to the JVM, well, it retries to adapt the code, the native code, to the workload. So you can have very optimized code. This is great for long-running processes. This is really good. That's the reason why the JVM was always on par or even outperformed C or C++ code before. It's because of this like continuous improvement, this adaptiveness. When you statically compile, you compile once and then you've got the native code, and if the workload changes, well, you are stuck with the native code. That's fine. But still, if we are containerized and if we think that, well, most of the time what will happen is Kubernetes will kill the containers and start new containers. We want those containers to start very fast. And even better, we want those containers to be as less memory hungry as possible. So I need to talk about something called GraalVM. And GraalVM is a JVM platform, so you can use it to run your bytecode as usual, but it's more than that. It has a lot of different features. The first thing that I need to mention, it's polyglot. So it's not only about Java. You can also do Python, C, Ruby, JavaScript. And if something doesn't exist, the language you want doesn't exist, well, you can create your own language or implement an existing language on top of Graal using a framework called Truffle. And actually, the Ruby implementation is called Truffle Ruby because it uses this Truffle framework. There is also something that stirred a lot of interest, is called Substrate VM. And Substrate VM is a way to create a native executable out of your bytecode. Then you get back to the world of native executable. So you start up much faster, you consume less memory. But on the downside, you cannot adapt the bytecodes to the existing workload. But in the world of containers, that's not such a big issue. So let's see how it works. The first thing is we need to, let's say, when you do this creation of the native code from the bytecode, you will lose a lot of features. You do this kind of ahead of time compiling. So your Graal VM, your substrate VM compiler, will try to follow the path that usually is followed at runtime. It will be followed at compile time. And you might use, or I've heard about reflection. Reflection is the way that basically you can call code at runtime that is not available at compile time, and this wrecks evoc with ahead of time compilation. So you need to make substrate VM aware of those passes, otherwise they will get lost, and at runtime you will have lost code. And one way to do that is to have a dedicated Java agent and to run your normal standard JVM with these agents. And you run your program at runtime, you go on every nook and cranny, and this agent will record all those config files for you. So this is this step. And the next step is to actually finally use it. So I will check out this one, and I will takes a bit of time. And again, I will kget pods, kdelete pod custom operator. Now I'm on the tag 2.1, k apply f deploy .yaml get pods. As you can see, it's very, very fast. And the good thing with that is now if I docker images grep operator and I find the 2.1 here, you can see that it's about 1/4 of the size of my 200 stuff. So, and the next step is actually to try to reduce the size even more. So the latest one, the super optimized one, which goes in a talk that can go a bit, it will be a bit longer, is to be like close to 40 megs. And 40 megs is actually an acceptable operator. Not perhaps on par exactly with Go, but very, very close, to say the least. So in this talk, we saw what are controllers. So just a control loop that checks the existing state and tries to move the ecosystem from the existing state to the desired state. We saw the difference between a controller and operators. So operators operate on a CRD. If you know how to write a controller, you know how to write an operator. We saw that actually you could write a controller with Bash. There is no tech stack required, just HTTP and JSON. And if you are in the JVM world, or if you are in any world, well, you can reuse your skills. So in that talk, I demoed the JVM, but you can do the same in Python or whatever. And even if you want to use Python and you have in the end a massive, huge executable, and it takes a long time and it consumes a lot of memory, well, you can always use the Graal VM version that will take your Python and make it a native executable. So thanks for your attention. You can read my blog. You can follow me on Twitter. And more importantly, if you need a bit more time and if you want to check every step, because there are steps that I skipped due to the duration of the talk, you can check the GitHub repository. It's available. Thanks a lot, and I wish you a good conference.
Thanks for your interesting talk, Nicolas. It was a pleasure to watch and to learn about how to build Kubernetes operators with Java. As you mentioned, the size is quite huge if you take the original JVM. Do you think that, I think there is a project in the making, like to split up the original JVM into smaller packages that you don't need them all? This would also lead to smaller
It's
images.
already the case. Yeah, it's already the case. So basically, the point is you first you need to be on Java 9 at least. And that means that afterwards you need to say, hey, I'm like modularizing. This is called the Java module system, Java platform module system, GPMS. And basically you are saying, hey, I want only this part of Java and only this part of the GDK and only. The thing is, yes, but first it's an effort to modularize your own application, but that can be done. The second thing is you can only depend on modules in that case, meaning that you need to use libraries or frameworks that are modularized themselves. And the state of this modularization is very, very poor. Actually, there are, I mean, I took the 20 most used libraries from another blog post and checked the state 1 year ago, I think. And it was really very bad. Like only two of them were really modularized, and half of the rest was module compatible. Meaning that if you want to do that, you need by yourself to when you declare a dependency to create their modules for them. With a non-trivial application, it's no fun, really. It takes a lot of time. So that's one way to approach it, but there is no way that it would be acceptable in a non-trivial project. In that case, GraalVM is the way. I mean, GraalVM doesn't try to say, hey, you should do this, you should do that. It says, okay, I will take your bytecode. I will just try to do as if I was executing the code, and then it will follow the path. And then it's up to you to decide, hey, okay, you remove this path, I need it. And as I mentioned, you can do it using an agent. And by using these agents, you basically record it. So basically, you can have like a mega integration test that goes to everywhere in your application. Then you record every path at runtime, and out of this scenario, you get the reflection and every configuration file already done for you. I think that would be the way to go. That's the way I would go. Again, like GPMS, very good idea. Implementation is very poor in the real world.
Okay, thank you. Our viewer Roman has a question, and he asks, what about testing? Do we have an option here? I think he means that somehow unit testing or integration testing, the Java operators, maybe you have experience with it or can hint to something that he could use to do this?
Yeah, sure. Well, I don't know if I experienced, but I've written a book about integration testing, but I can talk about that for 1 hour, and I'm not sure I have that level I have that much time. But basically, for unit testing, you just use your controller and you mock the dependencies, and then you check that by sending this input into this method, then you get the output that you want. It's just like that.
Normal software.
And if you want to do integration, sorry?
No, it's just like you would test a normal component of your software. You just slice it down into tiny methods or modules, and then you would test these individually. And that's the same with the operators.
Exactly. I mean, if you can unit test servlets, for example, servlets only runs on containers, but basically you can take a servlet and test do get method by like sending a mock HTTP request and checking that the mock HTTP response, you have the stuff that you want. It's not super easy. If you do it just by yourself, it's not super easy, but it's acceptable. And here you can do the same. Basically, what you will check is are you sending the right HTTP requests to the API server. So how I would approach it is I would say, okay, like for integration testing, I'm talking about that. I would I would put a proxy between a controller, the normal controller, and the API server, then record when I send this HTTP request, I get this HTTP response. Then I would do that as well, saying, hey, I will send this HTTP request. Is it the same as the proxied recorded one? Yes. Test passes, fails, and test doesn't pass. Why? Is it because it's something random, then I can ignore it? Or it's because that's something meaningful, and then I need to change my test or change my code somehow?
Okay, I see.
But I really appreciate that question. Not a lot of people think about testing, so that's really, really great question.
I think people think about testing who were in the project which didn't have tests, and they learn it the hard way, probably. So if our viewers have questions, they can just put it in the chat as usual, and we will try to answer them, but I'm sure you can do it. I think actually what you've done right now, like writing operators in Java and putting them on the GraphVM, you are this is a trend. I think in today's modern application, they consist mostly of microservices, and within those microservices, it doesn't really matter if people want to use Python or use Java or use whatever they are used to. As long as you have this ecosystem of microservices working together, everybody can use what they're most familiar with or what they like. And I think what you did is like you took it one step further and used this paradigm for Kubernetes, since Kubernetes abstracts these microservices or components, which can then interact with each other. And you, put it one layer down, like saying, okay, then I want to have Kubernetes so modular that we can use what we are used to write Kubernetes operators or plugins. So quite cool. Yeah, Nicolas, thank you very much. I'm just peeking here if we have another question. You just on your last slide, you put out your Twitter handle. You might want to put it in the chat as well on Hopin, so everyone can follow you and ask you questions and follow up there. I think that will be cool for these people to get in touch with you, and maybe if a question comes to mind tomorrow, they can reach out to you and ask you.
Sure. Feel free to ping me. If you listen to me, feel free to ping me. If you have questions, my DMs are open. They are there for that.
Okay. So one last sentence from you. Do you think Kubernetes will be the new standard layer in the cloud to avoid vendor dependency?
Yes, vendor lock-in. I'm very, very careful about this cloud stuff, because once we get, that's very funny. And I remember in the 90s, the 20s, and everybody was saying, hey, Microsoft is very bad. We are locked in. We cannot go out. Now they're all jumping on the cloud vendors without any, hey, let's all use AWS features because they are so cool. Because now you need a certification. It's so complex, you need a certification, not only one, but you have multiple layers of certification. If I were a decision maker, I wouldn't use any feature that got me locked into any vendor cloud provider. I would much rather use Kubernetes, perhaps with less features, but at least I would be sure that just in case I could switch easily, or let's say with at least a pass of migration pass. 13-14 years ago, I was in the Java ecosystem, and I did a migration from a server called Oracle 4J server, like old server, old application server, to WebSphere. And normally the Java EE standard lets you do that blindly without any hassle. There were hassles, of course. There were some strange stuff, for example, the EGB specification at the time was very, very light. So basically everybody did his own stuff on one server. spaces were not significant. On the other server, they were. So you had to do a couple of stuff. But it was possible. It provided a clear way. It was not a project. It was just a one-man effort of several months. And I believe Kubernetes is the application server standard of today's. So if you are using the cloud, be very, very aware of the risks of vendor lock-in. And if you want to mitigate that risk, of course, Kubernetes is really good for that.
Yeah, I can see this. And I work actually now for 2 multinational companies, and they're using the cloud heavily and migrating their on-prem data centers to the cloud. But they're also very wary and say, okay, we don't want to make the mistake that we did with Oracle 20 years ago. So we have to have some intermediate layer which abstracts, and we want to avoid vendor dependence or the vendor lock-in, of course. Yeah. And all cloud providers really only use or try to get you to use the proprietary services so that you're locked in their ecosystem. Okay, thank you very much, Nicolas. It was a pleasure to talk to you.